The bit rate and baud rate. Bit rate is defined as it is the number of bits per second. The number of bits per second is defined as bit rate, and baud rate is defined as it is the number of symbols per second or elements per second. Suppose if n indicates the number of bits per symbol, then the baud rate R is equals to bit rate by n. The baud rate R is equals to bit rate by n. So the total number of symbols here L is equals to 2 to the power of n. The total number of symbols L is equals to 2 to the power of n. And the bandwidth is given by defined as 1 by minimum pulse width possible. 1 by minimum pulse width possible. If the pulse width is TB, then the bandwidth is equals to 1 by TB, which is equals to RB. So which is equals to the bit rate. So if the minimum pulse width is TB by 2, then the bandwidth is equals to 1 by TB by 2, which is equals to twice that of the bit rate, 2 RB. Now let us see a simple example. An analog signal carries 4 bits per symbol elements. If 1000 signal elements are sent per second, find bit rate and total number of elements. N bits per symbol, n is equals to 4 bits per symbol element. So it was given that the analog signal carries 4 bits per symbol element. So n is equals to 4 bits per symbol elements. And if 1000 signal elements are sent per second, so 1000 signal elements, that means that the baud rate was given as 1000 signal elements per second. Therefore, the bit rate R is equals to baud rate into n. Therefore, R is equals to n into R, which is equals to 4 into 1000, 4 kbps, 4 kilobits per second. And now the total number of elements are, the total number of elements L is equals to 2 to the power of n. 2 to the power of n. Therefore, 2 to the power of 4, which is equals to 16 number of elements. And next problem is, an analog signal has a bit rate of 8000 bits per second and baud rate of 1000 baud. How many data elements are carried by each signal element, and how many signal elements do it? So here what was given? 8000 bps. That means the bit rate capital R is 8000 bps and baud rate is given by 1000 bauds. And we need to calculate the how many data elements are carried by each signal element. That means we need to calculate n, the total number of bits per second. And how many signal elements do we need? So what are the total number of signal elements L? So as from the definition, R is equals to baud rate is equals to bit rate by n. So n is equals to bit rate by baud rate. So capital R by small r, that is 8000 by 1000. That means 8 bits per element. So 8 data elements are carried by each signal element. And how many signal elements do we need? So the total number of signal elements are 2 to the power of n, 2 to the power of 8, which is equals to 256. 256.